So we actually have two objectives today. We're going to find the roots of quadratics using factoring as a strategy. We're also going to learn how to write the equations of quadratics if I give you the roots. So I'm going to tell you the roots, and from that you'll be able to tell me what the equation of the quadratic is. So before we begin here, some review real quick. What are roots? Those are x values, good. And specifically, which x values are they? They're the x-intercepts. Yeah, so it's where it touches the x-axis. So like if you have a graph, we already know what quadratics look like. They look like a U shape, right? Well, these things here are the roots. They're also known as zeros. They're also known as x-intercepts. And what do these 2 points have in common? What number do they both have in common? 0. Which variable is the 0? The y value, because it's on the x-axis, right? So how we find roots is you plug 0 in for y and you solve for x. Now, like I said, we did that before already. We did it with what are they called? The vertex form. But today we're going to do it with the standard forms. Okay. And the way that you do it with standard form is you use factoring. Right. All right. So the directions say use factoring to find the roots. Use factoring to find the roots. Okay. So number 1. Step 1, guys, when you want to find the roots, is you're going to plug 0 in for y, because when you're looking for roots, the y value is 0. And instead of using x, they're using other letters here. It doesn't really matter what letter they use technically, but there it is, 0. Now, we haven't, I don't know the last time we've been factoring it. It's been a little bit. But there are three ways to factor. So we have the GCF method. You always look for a GCF first, a greatest common factor. After that, if there's 2 terms, maybe it's a difference of squares. In that case, you would do x minus a, x plus a. If there's 3 terms, you can use the box method. Okay. I'll pause there in case you guys want to write. Okay, so you always start by looking for a greatest common factor. So you ask yourself, do these 2 things have anything in common? So in the way that you answer that is, you're going to look at 2 things. You're going to look at the coefficients first. So 7 and 2. Is there anything that you could divide out of 7 and 2 that they would have in common? No. So we'll skip that. Then you look at the variables. This guy has b squared, which means there's 2 b's there. And this one has 1 b. So how many b's can I take out? Only 1. You can only take out however much they're both able to give. They're both able to give 1. This guy could give 2, but this guy can only give 1, so we'll take out only 1. So if I take out a b here, what would be left on the inside? 7b minus 2. Okay, let's review. We've kind of been taking a long time here. I've had you guys write this down, slow this down a little bit. But step 1 is to set it equal to 0. Set it equal to 0. That's what we did first. Step 2 is to factor. In this case, I did a GCF method. Okay, but it won't always be GCF. It could be one of these other 2 methods down here. The next thing that we're going to do is we're going to use something known as a zero product property. I'm pretty sure we already learned that this year. I'll write it out. Zero product property. Maybe you guys can refresh my memory. Have I used those words this year? Yeah. Okay, good. I get confused. I teach pre-calculus, and there's a lot of overlap. All right, so here's what the zero product property says. It says that if you have two things that are multiplied together that equal 0, then one of them has to equal 0. So either b equals 0 or 7b minus 2 equals 0. And we're just going to solve both of those. Okay, so this one is done. This one we have to do a little work on. Okay, so these are the roots. If you were to graph this quadratic equation, that's where it would be touching the x-axis. It would be touching the x-axis at 0, and it would be touching the x-axis at 2/7. 0 and 2/7. So once again, we got 3 steps here. Set it equal to 0. Factor it. Zero product property. Okay? And that's just fancy words for saying set them both equal to 0. And so. Take a look at our second one there. All right. So this time I'm going to ask you for a little help. Aaliyah, what do I do first? Correct. Nice job. You make the y value a 0. That's how you find roots. That's like the main step. It's not the hardest step, but that's the main step. That's how you find roots, is to make the y equal 0. All right. Bidal, what's the second step? Step 2. Okay, not bad. So what you're referring to is like what we did in the last one, which is factoring. And now in this case, okay, I think there is something we can take. It's not an n. And the reason I can't take an n out is because the 24 doesn't have one. But what you're observing there is correct comparing to the last one. We do want to factor on this one. So when we factor, what's the first thing we look for, Steve? We're gonna do that in a second, but before we get there, we want to look for something else. Let me go to Edwin. Let's look for a GCF. So now, Bidal was saying n. Why can't I take an n out? So 24 can't afford that, so we can't take an n out. He doesn't have an n, so we can't do it. But let's take a look at the coefficients. Can anything come out of those 3 numbers there? 4. That's it. Okay. A lot of you guys might have been thinking 2, but I agree. I think 4 is good. You want to get the biggest number out that you can. Let's see if that's the biggest one. Why don't you guys see what you think goes in the blank there? I'll call on you in just a second. See if you can fill in that blank. Okay, good. And the way that we get that is we're dividing these 3 numbers here by 4 because we're dividing it out. So there's that. Now sometimes whenever you take out GCF, maybe you didn't take out the biggest number possible, but you could tell to just look at these. Is there anything that these have in common still? 5, 13, and 6? No. So we're good. So that was a good call. When I first looked at it, I was just thinking 2, but if I did that, there would still be more to take out. But there's that. Okay, now we're still not quite done factor. I'm going to go back to what Steve said earlier. Steve, what do we need to do now to factor this? Yeah, there we go. This one has 3 terms in it, so we have to use the box method. It's been a little bit. I'm going to give you guys about 3 minutes just to kind of review the factoring strategy a little bit here. Well, let me get you guys started at least, because I think it's been a little while since we've done this. Adriana, what do I do first?
You put the first number in the parentheses and the top.
Good. Yep, so this number in the front here goes here. And at that point, if you were lost, I bet you guys know now what goes here. The -6 does. Now what we want to do is we want to find two numbers that multiply to make 5n squared. And we want to find two numbers that multiply to make -6. Then you complete your box. How do you know if you guessed the right numbers? If these two numbers here, when you're all done, these have to add up to that middle number. Okay? So go ahead and see if you guys can, just go as far as you can. I'll give you like about 2 minutes or so. If you don't get it, it's okay. We'll walk through it. But this is just review, a chance to waken your minds up to something we haven't seen for a while. So what are two things that multiply together to make 5n to the second power? Yeah, 5n and n. I mean, it's pretty much our only option. Can't really do much else than that. You always have to split the variables up evenly. So you couldn't put all the n's on this side and no n's on the top. You always have to split them up evenly. The coefficients can be split up in a variety of ways, but 5 is just 5 and 1, so there's no other way to split that up. That's got to be the answer. 6 could be an issue, though, because there's two ways to get 6. You could do 2 times 3 or 1 times 6. So now usually, which would be the better pair to pick? I usually suggested which pair? 2 and 3. The middle numbers, the smaller, the ones that are like less extreme. Just usually, not always, just usually. So I'm going to put a 2 here and a 3 here. Okay, now, am I right? I don't know yet, so maybe you don't want to write that down yet. But we're going to fill it in and see. So what goes here? 10n. And how about here? 3n. Now, notice this is a negative 6, right? So now, here's the bothersome part about this. Doesn't this make 13? It does, but I got a problem because I need a -6, which means one of these has to be negative. And if I make this one a negative, then the 10 will be negative. And if I make this one a negative, then this one will be a negative. But either way, I'm going to lose my 13, aren't I? No, because if I made them both negative, then that's going to make my 6 positive. So that won't work. What were you going to say back there, Miles? Can you say it again? I think you're onto something. Because you said something about 15, right? And so I see where that's coming from. So let me elaborate a little bit. But before I do that, because I think he's right, but let me explain where he gets his 15 from. When your first guess fails, what are you supposed to do? Switch the numbers around. Don't get rid of the 2 and 3. Don't abandon them and go to 1 and 6 yet. Let's give them one more try, and let's reverse the 3 and the 2 around, right? So I'm going to put this guy up here now. And do you guys see where Miles is getting his 15 from? Oops. Let's try that. So 5 times 3, there's that 15 that Miles was talking about. And there's my 2n. Now, 15 and 2 can make 13 if which one is negative? 2. And there's my negative I needed. So it looks like we have a good factorization there. So when it doesn't work the first time, just switch the numbers. If that doesn't work, then that means 3 and 2 is not the correct choice to go with. Try 1 and 6 instead, and so on. It's a guess and check thing. You just kind of got to keep messing with it. So we still have this 4 here. We have n plus 3, and we have 5n minus 2. Okay. That was a long step. So step 1, set it equal to 0. Step 2, factor. Now we're done. Kimaya, what's the last step in trying to find these roots? You take really good notes. I bet you wrote this down. Remember on the last problem I did, I wrote down some words on the side? What was the last one? The last step I wrote down on the first example. Okay, that's okay. Maybe I went too fast. You can get a chance to write it. But what do you think, Crystal? We're going to use a zero product property. And what that means is you're going to set everything equal to 0. Now, I'm not going to set this one equal to 0. There's no in. So it's not going to help you. And besides, 4 is not equal to 0, so there's no point in writing that. But we will do this. N plus 3 equals 0. 5n minus 2 equals 0. And we're going to solve both of those. Why don't you guys go ahead and work that out, and I'll ask you what you got there. It's called the zero product property. Zero product property. I think I gave 4 there. Is there an extra pair of notes there for now? There should be one. I put 4 there. All right, there we go. So Miles, what did you get for this one here? The bottom n plus 3 equals 0? Equals what? Good. And Steven, what did you get for the second one here? Okay. Next question is going to Denise. Denise, what do these numbers represent? That's right. It's where this quadratic equation would touch the x-axis. So as you guys are seeing, this is the biggest step, but that's review. But that's the biggest step. So step 1, set it equal to 0. Step 2, factor. Step 3, set them equal to 0 and solve. Okay. So I think you guys have a student practice there in your paper. Let you guys mess around with that for a little bit, and then we'll move on to our next segment if we have time there. So what we're going to do next is we're going to build on this to work backwards. What I'm going to do is I'm going to give you the roots, and you're going to take those roots and turn them into an equation. Okay? So that's the goal. Let's see how we do. See if time allows us to do that. All right, so you don't need to write this, but here we go. Let's review. Finding roots by factoring. Step 1, set it equal to 0. Step 2, factor it. Step 3, set them both equal to 0. Finally, solve, right? So that's finding roots. But we're going to work backwards. So what do you guys compare these two things? What do you notice about the 7 here and the 7 here? They're just opposite signs. That's it, right? Same thing here. -1, +1. So if you want to change this back up into this, all you have to do is put x, opposite sign, and then the number equals 0, right? So that's what we're going to do here. Watch. X equals 3. What would that be? It would be x minus 3. And this would become, instead of x equals -4, I would have x plus 4 equals 0. And what these two binomials are, is those are my factors that used to be getting multiplied together, right? And then I can just multiply this together, right? And I've got my equation. So you see how you can work backwards from your roots? You can take your roots, turn them into factors, and then multiply them together. Okay? Now, it'll be a little bit more complicated than that because sometimes there's a number in the front here that we have to find, a constant. But other than that, that's pretty much the process. So, here's that. How to find the equation of a parabola just using the roots. the R1 and the R2, those represent the roots, okay? A is just some constant, you know, it's the one that tells you whether it's a happy face or a sad face. You guys can imagine that if I tell you two roots, couldn't that be a happy face or a sad face? It could be either one. So we don't know what the A is, so we have to find the A. But what I'm going to do is I'm going to give you the two roots, and then I'm going to give you another point. We'll use that to find the A. After that, we'll be able to write our equation out. So let's do one of these. All right, so example 1. Use the points on the graph provided to find the equation of the parabola that has the following points. All right, so I'm going to graph this real quick. -2, 0, -1, 4, and 3, 0. We can kind of roughly sketch a parabola there, right? So I want to find the equation of that parabola. All right. What's one of my roots, you guys? -2, and we only need to put the x value, but yeah, -2. So right here is one of my roots, right? What's my other root? 3. Right there. That's where it touches the x-axis, right? Oops. So we'll call that R2. Okay, now notice I gave you another point as well. I gave you two roots and a point. This is just going to be x, and this is just going to be a y. All right. So I gave you this little formula on the last page. So let's write that. All right, so step 1, we're going to plug in R1, R2, X, and Y. We're going to plug in those 4 numbers there. Okay, so A is going to stay there. What's the X value? -1. What's my R1? -2. Notice I've got a double negative there. One of the minuses comes from here. The other one comes from here. So there's 2 negatives on that one. Okay, so they want the x again. What's the x again? Good. And what's my R2? Good. And then finally my y value? Okay, the next thing that we're going to do, guys, after you plug in those numbers, we're going to find that A, that missing number we don't know. So let's find A. And the way we're just going to simplify and solve. So, first of all, what is -1 minus a -2? I want you guys to take a second to work that out and see what you get. What is -1 minus a -2? Just remember, these both become a plus, right, when you have double negatives. What do you guys get? Yeah. So if you change that to a positive, that's like 2 take away 1, which is, how about this one here? -1 take away 3. -4. We're still trying to find A. We haven't done that yet. Now I'm going to multiply these together. A times 1 times -4. Yeah. So 1 times -4 is just going to be -4 times A. I just like to put the A behind the number. It looks more normal that way. Can we find A yet? Have we found A yet? No, we still need to find it. So what do I need to do now to find A? We're going to divide. So I end up with A equals -1. That makes sense. Can somebody tell me why that answer makes sense? Yeah, so Edwin's remembering that A is the number that tells you whether it's a happy face or sad face. This is negative, which means it should be a sad face, and sure enough, that parabola there is a sad face. So that answer makes sense. Okay, so now step 1, plug in your R1, R2, X, and Y. Step 2, find A. Step 3, can I, well, I'll just erase this. Oh, it's one of those days. Sometimes my eraser doesn't want to work right. I don't know why it works some days. Other days it doesn't. Okay. Okay, so now for step 3, we're going to plug in 3 things. R1, R2, and A. But this time we're not going to be plugging in the X and the Y. Just those 3 things. Same formula as before. So we're only plugging in 3 things. R1, R2, and A. So what goes here? -1. What's R2? I'm sorry, R1? It will become +2, but R1 is -2, right? But it will become a +2 because of the double negatives, but I'll get to that in a sec. And then, what is R2? R2 is 3. And like Denise said, I'm just going to change that to a plus. Now technically that's the answer, but I want to write the answer in standard form. Okay, but technically that's an answer, but I want it in standard form. So let's do this. I want to multiply those together. Okay. So let's do that. X plus 2 and X plus 3. How do I multiply those together? A little more complicated than that. Of course it is, Mr. Bailey. It always has to be. Box method. No, that's too small. So X plus 2 and X minus 3. So what goes here? X squared here. 2X here. So we have X squared. I'm going to put these together. -3 take away, I'm sorry, -3x plus 2 is -1x and then minus 6. So, box. Multiply it using the box method there. What do you guys think I'm going to do last? I'm going to distribute. You got that little 1 in the front. So negative x squared plus x plus 6. All right. So I think that there's a lot of steps in there, and I would say that's kind of a tough problem. And I'm not comfortable saying you're good to go now. I would like to practice that a little more. So I think what I'm going to do is I'm going to say consider that a preview, and we'll talk about this more tomorrow. I'll change your homework so you don't have to do these particular problems, but we'll talk more about it tomorrow. But yeah, because we're also going to do word problems with this kind of stuff. So the word problem's not that bad. It's just this part. But the word problems will seem that much harder if you don't know how to do this. So we'll stop here for today. We won't do a student practice right now, but we'll pick it up again tomorrow and do the same thing. All right. So that's where we'll kill it for